Welcome, cosmic explorers, to another journey into the profound mysteries of our universe. Tonight, we embark on an extraordinary expedition, not into the distant stars, but into the very fabric of perception itself. The unseen worlds that surround us, shaped by the unique senses of every living creature. As you settle in, whether you're drifting off to sleep, finding focus in your work, or simply immersing yourself in the wonders of science, I invite you to share your thoughts. Hit that like button and consider sharing this journey with others. Let's delve into the intricate tapestry of sensory ecology. Welcome back, curious minds, to another journey into the intricate tapestry of existence. Tonight, we delve into a realm where reality is not a fixed, universal truth, but a symphony of countless interpretations, each unique to the perceiver. We're stepping into the fascinating world of sensory ecology, a relatively new, yet profoundly insightful field that illuminates how life experiences the universe, one unique Umwelt at a time. For centuries, science has largely focused on the tangible exchanges of matter and energy within ecosystems. We've meticulously mapped food webs, charted nutrient cycles, and quantified biomass. But what about the invisible threads, the whispers and echoes, the hues and vibrations that truly shape an organism's life? This is where sensory ecology emerges, asking fundamental questions. What information does an organism gather from its surroundings? How does it gather it? And most importantly, why is that information so vital to its survival and reproduction? Imagine, if you will, the world through the eyes of a hawk, soaring thousands of feet above, its vision so acute it can spot a field mouse camouflaged in tall grass. Now, shift your perspective to a bat, navigating a pitch-black cave, painting a detailed sonic landscape with its high-frequency calls. Or consider a shark, sensing the faint electrical impulses of a hidden fish long before it ever sees or smells it. Each creature, a living sensor, filtering and interpreting the deluge of environmental data through its own specialized apparatus. This concept, the perceptual world of an organism, is beautifully encapsulated by the German word Umwelt. It describes the unique subjective reality experienced by each species, shaped by its sensory filters. Our human Umwelt, for instance, is heavily dominated by vision. We see a vibrant spectrum of colors, distinguish intricate details, and rely on visual cues for almost every aspect of our daily lives. But for many other species, their perceptual priorities are entirely different. Consider the humble earthworm. Its Umwelt is likely a rich tapestry of chemical gradients and subtle vibrations through the soil, a dark, tactile, and olfactory world largely invisible to us. Or think of a moth, drawn irresistibly to the scent of a female's pheromones from miles away, a chemical beacon guiding its journey. We perceive a quiet evening. A moth perceives a swirling cloud of potent, alluring messages. These senses are far more diverse than our familiar five. Beyond smell, taste, touch, hearing, and sight lies a spectrum of remarkable abilities. Pheromone detection, a sophisticated chemical language. Nociception, the perception of pain, essential for survival. Electroreception, the ability to detect electrical fields, crucial for aquatic predators like sharks and platypuses. And perhaps most astonishing, magnetoreception, the innate capacity to sense and utilize Earth's magnetic field. This magnetic sense acts as an invisible compass for a vast array of species. Migratory birds, unerringly charting courses across continents and oceans, guided by the Earth's subtle magnetic lines. Marine turtles, newly hatched on sandy beaches, intuitively heading out to sea. Honeybees, meticulously constructing their hexagonal comb cells, aligning them with the planet's magnetic grid. Even salamanders, discerning the subtle magnetic shifts at the interface of land and water. For these creatures, the Earth isn't just a physical landscape. It's a vast, dynamic magnetic map. Sensory ecologists, in their quest to decipher these hidden worlds, strive to understand which environmental and sensory cues are paramount in determining the behavioral patterns of different species. And in recent years, this knowledge has become more than just academic curiosity. It's being widely applied in critical fields like conservation and wildlife management, offering new avenues to protect and sustain our planet's biodiversity. One of the most profound ways humans have reshaped the sensory landscape for other species is through altering noise levels. Communication, in all its forms, is the bedrock of interactions within ecosystems. Many species rely on vocalizations for crucial information, identifying potential mates, warning of approaching predators, or locating vital food sources. But as human presence expands, our activities inadvertently transform acoustic environments, often drowning out these vital messages. Imagine a bird attempting to attract a mate with its intricate song, only to have its melody lost amidst the roar of traffic. Or a pack of wolves trying to coordinate a hunt, their calls obscured by the incessant hum of industrial machinery. Humans modify acoustic environments in myriad ways. By increasing background noise, by altering habitats that naturally dampen or amplify sounds, or by changing the composition of species, thereby impacting the acoustic tapestry of a region. These changes, often subtle to our ears, can profoundly mask the vocalizations of countless species. Sensory ecologists have been particularly keen to understand how organisms react to these anthropogenic alterations, recognizing the immense power we wield in shaping these delicate acoustic ecosystems. The impacts have been particularly significant for species that depend heavily on auditory cues for foraging and communication. Take bats, for instance, those enigmatic nocturnal flyers. They navigate and hunt using ultrasonic echolocation, emitting high-frequency sounds and interpreting the returning echoes to construct a detailed acoustic map of their surroundings. But when these auditory cues are masked by loud background noises, their extraordinary efficiency at finding prey plummets. Studies have shown that foraging bats actively avoid noisy habitats, likely due to this crippling decrease in their hunting success. It's a silent, unseen struggle, but one with profound implications for their survival. Bird communities, too, bear the brunt of increased noise pollution. Ecologists have observed shifts in avian community composition, a decline in overall diversity, and even a decrease in reproductive success in noisy areas. Some species, in an attempt to cut through the din, have even been documented altering the frequency of their calls, essentially shouting louder or at a different pitch to be heard. Research has quantified this impact. Many bird species will alter their overall behavior, affecting reproduction, abundance, and even stress hormone levels, at noise levels greater than or equal to 45 decibels. Terrestrial mammals experience heightened stress and reduced reproductive efficiency at noise levels between 52 and 68 decibels. These aren't just minor irritations. They're physiological stressors that ripple through entire populations. Anthropogenic noise isn't just the incidental byproduct of human activity, like the rumble of construction or the steady drone of traffic. It can also be intentionally produced, as with sonars used for underwater mapping or seismic exploration that measures seismic waves for oil and gas. These studies underscore the critical importance of auditory cues and have sparked urgent calls for the preservation of what ecologists call soundscapes, the collective, natural acoustic signatures of ecosystems. The marine environment presents an even more complex acoustic challenge. Because light penetration diminishes rapidly with depth, hearing often becomes far more crucial than vision for navigating, communicating, and surviving in the ocean's vast expanse. Moreover, sound travels approximately 5 times faster in water than in air and over far greater distances, making it an incredibly powerful medium for marine communication. The sounds of the ocean are vital for the survival and reproduction of its inhabitants. Yet, over the last century, human activities have increasingly flooded marine environments with unprecedented levels of artificial noise. These sounds can severely impede the ability of fish and marine mammals to hear, interfering with their communication, their ability to avoid predators, detect prey, and even navigate. Whales, for example, are particularly vulnerable. The intense noise from shipping, sonar, and offshore construction can lead to reductions in their foraging efficiency and mating opportunities. Extreme noise can even cause physical ear damage for whales, impairing their vital echolocation abilities for orientation, and in some horrific instances can startle them so badly that they engage in stranding as a flight response, tragically leading to their demise. The burgeoning development of offshore wind turbines, while crucial for sustainable energy, has presented new dilemmas for conservationists. Ecologists are now diligently studying how the sounds produced by these massive structures might affect marine species. Initial findings suggest that the noises emanating from wind turbines could significantly impact the communication of marine mammals such as seals and porpoises. This research is directly informing development projects, with recent reports assessing the acoustic risks of offshore wind farms on fish communities, seeking to mitigate their impact on these delicate underwater soundscapes. Beyond sound, another fundamental element of our world that humans have dramatically altered is light, particularly at night. Light pollution, the excessive or misdirected artificial light, has become an increasingly serious issue, profoundly impacting species that rely on visual cues for navigation and survival in the nocturnal world. Consider a recent study on rodent communities. Brighter nights, bathed in artificial glow, led to noticeable changes in foraging behavior. Less predator-susceptible species, perhaps feeling more confident in the extended daylight, foraged heavily. Conversely, species highly vulnerable to predation significantly reduced their foraging activity, retreating into the shadows, a direct consequence of their increased nighttime visibility. For them, a brighter night meant greater danger. Birds, too, are heavily influenced by light pollution. Ecologists have meticulously documented how the bright lights on tall structures can disorient migrating birds, leading to millions of tragic deaths each year. These findings have not just been observed, they've guided urgent conservation efforts. The U.S. Fish and Wildlife Service, for instance, has developed comprehensive guidelines to reduce the impact of lighting on migratory birds, advocating for limits on tower construction, restrictions on tower height, and strategic placement away from critical migratory zones. Programs like the Fatal Light Awareness Program, or FLAP, in Toronto have demonstrated tangible success by collaborating with buildings to reduce light emissions, dramatically decreasing bird collisions. And then there are the iconic sea turtles. Studies have unequivocally shown that artificial lighting disrupts the orientation of newly hatched baby sea turtles. Instead of instinctively heading towards the brighter horizon of the ocean, they become disoriented, often crawling towards artificial lights on land, increasing their vulnerability to predators and ultimately increasing mortality rates within these already endangered populations. This wealth of information has led to the proposal and implementation of numerous innovative conservation and management strategies. The very same researchers who illuminated the plight of sea turtle hatchlings have suggested pairing light reduction with dune restoration efforts to improve their orientation and success. Furthermore, understanding the sensory ecology of sea turtles has inspired creative solutions to reduce bycatch rates by fishermen. Bycatch, for those unfamiliar, refers to non-target fish, turtles, or marine mammals that are unintentionally caught during fishing operations. Knowing that fish and sea turtles respond differently to visual sensory cues, scientists have devised a clever baiting system that is virtually undetectable to fish, yet far less attractive or even actively repellent to sea turtles. This ingenious method has led to significant decreases in turtle bycatch, all while maintaining fishing yields. One of the overarching goals of sensory ecologists has been to pinpoint precisely what environmental information is most critical in shaping an organism's perception of its world. This knowledge has become exceptionally relevant in our era of rapid environmental change and the proliferation of novel, human-modified environments. Scientists are now vocally calling for the integration of sensory ecology directly into conservation and management strategies. Sensory ecology, in essence, becomes a powerful tool. It helps us understand two critical aspects. First, why different species might react to anthropogenic and environmental changes in such varied ways. And second, how we might mitigate the negative impacts of these changes. For example, by understanding the intricate nature of soundscapes and their profound ability to restore ecosystems, scientists have made remarkable discoveries. Playing loud, diverse, healthy soundscapes, for instance, has actually demonstrated the power to restore once degrading coral reefs. These restored ecosystems, vibrant with their natural acoustic tapestry, become beacons of hope for future generations of coral reefs, supporting long-term stability and conservation management. Furthermore, sensory ecology has been effectively deployed as a strategic tool in controlling and eradicating pests and invasive species. This includes a diverse array of organisms, from agricultural crop pests to marine invaders, from cane toads to brown snakes. By delving into the vastness of perceptual worlds experienced by these different species, we can better inform conservation strategies, helping to prevent what are known as ecological and sensory traps, and crucially, reducing problematic human-wildlife interactions. This, in turn, can significantly increase the success rates of reintroducing species into new habitats and aid in the process of capturing and releasing animals to protect them from potentially dangerous sites. Let's delve deeper into these ecological traps. An ecological trap is a cruel irony of nature, an instance where organisms mistakenly choose poor-quality habitats over better, available ones because they misinterpret cues and incorrectly evaluate habitat quality. Man-made landscapes, with their novel environments and artificial materials, frequently present these deceptive scenarios. Organisms often misinterpret these human constructions for natural materials, leading them to select unsuitable habitats. Sensory ecology offers a pathway to mitigate these effects by clarifying precisely which specific information organisms are using to make these bad decisions. Think of it: asphalt roads or solar panels, which to certain organisms can appear identical to natural surfaces. Solar panels, for example, reflect horizontally polarized light, a visual cue that many insects perceive as water. Since these insects typically lay their eggs in water, they're drawn to oviposit on the solar panels. The tragic consequence is widespread juvenile insect mortality. To mitigate this devastating ecological trap, researchers have ingeniously broken up the shape of the solar active area on the panels. This simple modification made the panels far less attractive to the insects, significantly reducing mortality. A number of bat species also fall prey to ecological traps resulting from man-made surfaces. A fascinating study by Greif and Seamers revealed that bats determine the presence of water not by its actual wetness, but by the smoothness of surface. Consequently, bats frequently attempt to drink from smooth, non-water surfaces like glass, wasting precious energy and time, which can ultimately lead to a decrease in their fitness. Bird species are another group frequently ensnared in ecological traps due to their unique sensory ecology. A major focus in avian sensory ecology has been on how birds perceive large wind turbines and other towering structures. Every year, countless birds perish after colliding with power lines, fences, wind turbines, and buildings. The flight paths around these structures, ironically, act as forms of ecological traps. While birds might perceive these areas as good habitat or viable flight corridors, they actually increase bird mortality due to collisions. Sensory ecologists have directly linked these ecological traps to avian sensory ecology, particularly their vision. Researchers have found that while human vision is binocular and offers high frontal resolution, bird vision is far less so. Birds often lack the sharp, high-resolution frontal vision we possess, meaning they may simply not perceive large structures directly in front of them, leading to catastrophic collisions. Thankfully, a number of solutions have been proposed. One study demonstrated that birds respond differently to various airport lighting schemes, suggesting that altering lighting patterns could significantly reduce bird strikes. Other researchers have suggested that strategically placed warning sounds or visual cues on the ground might help reduce collisions. By adjusting the other sensory cues that birds rely upon, ecologists hope to reduce the presence of these avian ecological traps around human-built structures. Beyond conservation, sensory ecology has proven to be an invaluable tool in pest management strategies. Scientists have cleverly exploited the sensory systems of various pests, insects, marine animals, even amphibians, to develop highly targeted control methods. This involves creating individualized visual, pheromonal, and chemical traps. Visual traps, for instance, are critical in managing several insect species. The tsetse fly, a notorious vector of African trypanosomiasis, or sleeping sickness, is strongly attracted to blue colors. This remarkable sensory preference has been exploited by luring the flies into and killing them with blue fabric traps impregnated with pesticides. Scientists hypothesize that the flies are drawn to these blue fabrics because their hue resembles the color of the ground beneath a shady tree, a cool refuge the flies seek during the intense heat of the day. The exploitation of visual cues has also been used for the control of aphids and whiteflies. Many aphid species exhibit a strong preference for yellow colors, a sensory bias that scientists believe may stem from a preference for yellow leaves, which tend to have higher flows of accessible nitrogen sources, a vital nutrient for their development. Pheromones, those species-specific chemical cues, represent another powerful tool. When released, pheromones can profoundly influence the behavior and physiology of other organisms of the same species. Because pheromones are largely species-specific and often elicit strong behavioral responses, scientists and managers have harnessed them to lure and trap a vast array of species. This method has been particularly successful in insect populations, used to capture and control pests like sugarcane weevils, gypsy moths, invasive oriental fruit flies, bark beetles, and various Carpophilus species. By understanding the intricate chemical languages of these creatures, we can effectively manipulate their behavior for targeted management. The story of sensory ecology is a profound reminder that reality is not a singular, objective truth, but a symphony of countless interpretations. Each species on Earth, from the smallest microbe to the largest whale, inhabits its own unique perceptual universe, an Umwelt shaped by the exquisite tuning of its senses. As humans continue to reshape the planet, understanding these hidden realities becomes not just an academic pursuit, but an ethical imperative. By listening to the silent songs, seeing through different eyes, and feeling with unfamiliar senses, we gain not only a deeper appreciation for the boundless diversity of life, but also the crucial knowledge to protect it. Join me next time as we continue our exploration into these unseen worlds, delving into how these delicate sensory systems are further impacted by the human touch. As we delve deeper into the intricate tapestries of life, we uncover a profound truth. Communication is not merely a human construct, but a fundamental pillar upon which countless species build their existence. From the smallest microbe to the largest whale, organisms exchange vital information about their world, potential mates, lurking predators, the tantalizing scent of food. These exchanges, often subtle and imperceptible to our own senses, form the very bedrock of survival and reproduction. Yet, in our relentless march across the planet, humanity has become an inadvertent architect of silent worlds. Our activities, from the roar of engines to the thrum of industry, profoundly alter the acoustic environments that have shaped evolution for eons. These anthropogenic changes, whether intentional or an unforeseen byproduct, create a cacophony that can drown out the delicate whispers of the wild, making it increasingly difficult for animals to communicate, to thrive, and even to simply exist. Consider, for a moment, the ethereal dance of bats under the shroud of night. These nocturnal acrobats, masters of echolocation, emit ultrasonic pulses that paint a detailed sonic map of their surroundings. Every flutter of an insect wing, every rustle of foliage, is meticulously translated into a precise target. But when their delicate auditory cues are masked by the relentless thrum of human-made noise, their hunting efficiency plummets. It's as if their world, once vibrantly detailed, suddenly becomes blurred and indistinct. Sensory ecologists have observed this firsthand. Foraging bats actively avoid noisy habitats, a stark testament to the profound impact of these altered soundscapes. Their very survival hinges on the clarity of sound, and when that clarity is obscured, they are forced to retreat. The impact ripples further, reaching into the vibrant chorus of bird communities. Here, increased noise levels aren't just an inconvenience. They're a fundamental force reshaping entire ecosystems. We see shifts in avian community composition, a decline in species diversity, and even a measurable decrease in reproductive success. Imagine a bird attempting to serenade a mate or warn its offspring of danger, only to have its song swallowed by the ceaseless drone of human activity. Some species, remarkably, attempt to adapt, altering the frequency of their calls, trying to find a clear channel amidst the static. But this adaptation comes at a cost, demanding energy and focus that could otherwise be directed toward survival. Studies have meticulously quantified these thresholds of disruption. For many bird species, noise levels at or above 45 decibels, the equivalent of a quiet library or a refrigerator hum, can trigger changes in reproduction, abundance, and even elevate stress hormone levels. Terrestrial mammals, too, feel the strain, experiencing heightened stress and reduced reproductive efficiency at noise levels ranging between 52 and 68 decibels. These aren't just minor irritations. They are pervasive stressors that ripple through the physiology and behavior of entire populations. Whether the noise is intentionally produced, like the probing pulses of sonar or seismic exploration, or an unintended byproduct of our existence, the ceaseless roar of traffic, the clang of construction, the impact is undeniable. This growing understanding has led to a poignant plea from sensory ecologists: the preservation of soundscapes. Just as we strive to protect visually stunning landscapes, so too must we safeguard the delicate and complex sonic environments that define an ecosystem. The collective sounds of an ecosystem, the chirping of crickets, the rustle of leaves, the distant call of a predator, are not merely background noise. They're the vital symphony of life. Now, consider the profound importance of hearing in the marine realm, a world where light scarcely penetrates beyond the surface. Here, sound reigns supreme. It travels approximately 5 times faster in water than in air and traverses far greater distances, making it an indispensable sense for survival and reproduction. Marine species rely on sound for a myriad of critical functions: communicating with their kind, evading predators, locating prey, and even navigating the vast, featureless expanses of the ocean. Yet, over the past century, our activities have increasingly inundated these aquatic environments with a barrage of artificial sounds. The churning of ships' propellers, the thrum of offshore drilling, the sonic pulses of sonar systems, all contribute to a growing chorus of anthropogenic noise that can literally deafen marine life to the subtle, life-sustaining sounds of their world. This incessant clamor can impede a fish's ability to hear, disrupting communication, hindering predator avoidance, making prey detection a challenge, and even throwing off their intricate navigational systems. Whales, those magnificent leviathans of the deep, are particularly vulnerable. Their complex vocalizations, which travel for hundreds of miles, are essential for foraging, social bonding, and finding mates. Noise pollution can drastically reduce their foraging efficiency and diminish their mating opportunities. In extreme cases, intense noise can cause physical damage to their delicate ears, impacting their crucial echolocation abilities for orientation. There have even been instances where the sheer shock of loud, sudden noises has triggered mass stranding events, a desperate flight response often referred to as bleaching, as these colossal creatures flee the unbearable sonic assault. The rise of offshore wind turbines, while a crucial step towards renewable energy, introduces yet another layer of acoustic complexity to marine environments. Conservationists and ecologists are now diligently studying the sounds produced by these massive structures and their potential effects on marine mammals, such as seals and porpoises. This research is not merely academic. It is actively being applied to development projects, with reports assessing the acoustic risks of offshore wind farms on fish communities, aiming to find a delicate balance between human progress and the preservation of marine life. The world beneath the waves, once a realm of quiet grandeur, is increasingly becoming a noisy, disorienting place, challenging the very senses that have allowed its inhabitants to flourish for millennia. Understanding these silent worlds and the profound changes we impose upon them is not just a scientific endeavor. It is a moral imperative, urging us to listen more carefully to the subtle cries of a planet struggling to be heard. As the sun dips below the horizon, painting the sky in hues of orange and purple, a silent transformation begins. For millennia, the night has been a realm of mystery and shadow, a landscape navigated by creatures attuned to its subtle whispers and faint glows. But in a blink of an eye, in the grand scheme of Earth's history, humanity has dramatically rewritten the rules of the night. We've replaced the soft glow of the moon and stars with a dazzling tapestry of artificial light, altering the very fabric of nocturnal existence. This transformation, seemingly benign, has profound implications for the intricate dance of life that unfolds under the cloak of darkness. Our species, largely diurnal, often overlooks the sheer scale of this alteration. From sprawling urban centers that blaze with perpetual twilight to the scattered lights of remote outposts, we have fundamentally reshaped the planet's nighttime luminosity. This isn't just about making our surroundings visible. It's about casting long, artificial shadows that disrupt ancient biological rhythms and intricate sensory maps. Think of the humble rodent, a creature of the night, whose very survival depends on navigating the darkness unseen. A recent study, peering into the hidden lives of rodent communities, revealed a fascinating and somewhat alarming truth. Brighter nights, a direct consequence of our light pollution, have led to significant shifts in their foraging behaviors. Species that are less susceptible to predation, perhaps larger or with better defenses, seize the opportunity, foraging more heavily under the increased illumination. But for their more vulnerable counterparts, those whose survival hinges on remaining concealed, the brighter nights meant a heightened risk of exposure. They retreated, reducing their foraging activity, a survival strategy in the face of increased visibility. This simple change, seemingly minor, can ripple through an ecosystem, altering competitive dynamics and potentially impacting population sizes. The impact of light pollution, however, extends far beyond the scurrying creatures of the forest floor. Consider the aerial ballet of migrating birds, ancient travelers guided by the celestial compass of stars and the Earth's magnetic field. For these intrepid voyagers, our illuminated world has become a perilous labyrinth. Lights on tall structures, skyscrapers, communication towers, lighthouses act as powerful, disorienting beacons, drawing birds off course and often to their demise. Millions of deaths each year are attributed to these fatal attractions, a tragic testament to the disorienting power of artificial light on finely tuned natural navigation systems. The scientific understanding of this phenomenon has not been ignored. These stark findings have, in fact, catalyzed urgent conservation efforts. The U.S. Fish and Wildlife Service, recognizing the immense toll, has meticulously crafted a set of guidelines aimed at mitigating the impacts of lighting on migratory birds. These guidelines advocate for crucial measures, limiting the construction of new towers, restricting their height, and strategically locating them away from known migratory zones. The goal is to create safer passage for these aerial nomads, allowing them to continue their age-old journeys without encountering our blinding interference. Beyond these federal initiatives, local programs have emerged, showcasing the power of collective action. In bustling metropolises like Toronto, the Fatal Light Awareness Program, or FLAP, stands as a beacon of hope. Through dedicated efforts to reduce the light emissions from tall buildings, FLAP has demonstrably curbed bird collisions, proving that thoughtful design and awareness can make a tangible difference. Imagine the collective impact if such initiatives were to be adopted worldwide. But the perils of artificial light are not confined to the land and sky. They extend to the very edges of our continents, where the oldest and most vulnerable of creatures embark on their life's most critical journey. Baby sea turtles, newly hatched from their sandy nests, face an innate drive to navigate towards the brightest horizon, instinctively believing it to be the open ocean, a shimmering expanse of moonlight on water. However, our artificial lighting along coastlines often overpowers these natural cues, drawing the fragile hatchlings inland, towards roads, predators, and ultimately, away from their watery sanctuary. This disruption of their innate orientation has led to a heartbreaking increase in mortality rates within already vulnerable sea turtle populations. The urgency of this situation has spurred researchers to propose innovative conservation and management strategies. The very same scientists who uncovered the disorienting effects of light pollution on sea turtle hatchlings have suggested a powerful two-pronged approach, pairing light reduction initiatives with aggressive dune restoration efforts. By diminishing the artificial glow and simultaneously enhancing the natural contours of the beach, they aim to re-establish the environmental cues that guide hatchlings towards the life-giving ocean, thereby improving their orientation and overall success. Furthermore, our deep understanding of the sensory ecology of sea turtles has paved the way for ingenious solutions to another pressing threat: bycatch. Bycatch, for those unfamiliar, is the grim reality of non-target fish, turtles, or marine mammals being unintentionally ensnared by fishing gear. Knowing that fish and sea turtles exhibit distinct responses to visual sensory cues, researchers have meticulously devised a revolutionary baiting system. This innovative bait, while non-detectable to the target fish, is designed to be less attractive or even subtly repellent to sea turtles. The initial results of this groundbreaking method are incredibly promising, demonstrating a significant decrease in turtle bycatch without any noticeable reduction in fishing yield. It's a testament to how targeted scientific insight can yield practical, impactful solutions that benefit both human livelihoods and marine conservation. These examples underscore a profound truth: sensory ecology, in its exploration of how organisms perceive their world, provides an invaluable lens through which to understand and address the rapid environmental changes we've unleashed. It's not just about what we see or hear, but about understanding the myriad Umwelten, the unique perceptual worlds of every living creature. Indeed, a core objective of sensory ecologists has always been to pinpoint which environmental information is most critical in shaping an organism's perception of its surroundings. This deep understanding has become particularly crucial in our era of unprecedented environmental flux. It offers a vital framework for comprehending why different species react to anthropogenic and natural environmental changes in such varied ways. More importantly, it provides the roadmap for mitigating the negative impacts of these changes. Consider the remarkable example of soundscapes. We've explored how anthropogenic noise can degrade acoustic environments, but sensory ecology also reveals the astonishing power of restorative sound. By playing loud, diverse, and healthy soundscapes, recordings of vibrant, thriving ecosystems, researchers have found that they can actually help restore once degrading coral reefs. Imagine the very symphony of a healthy reef broadcast through underwater speakers, acting as a beacon of hope, drawing in new life, and kickstarting the process of ecological recovery. These restored ecosystems become living laboratories, demonstrating the potential for long-term stability and effective conservation management. But the applications of sensory ecology extend beyond restoration and mitigation. It has emerged as a powerful tool in a less romantic but equally critical arena: the control and eradication of pests and invasive species. From agricultural scourges to marine invaders and problematic amphibians like the cane toad or the brown snake, sensory ecology offers a pathway to highly targeted management strategies. By understanding the vastness of the perceptual worlds experienced by these diverse species, we can develop sophisticated approaches to prevent ecological and sensory traps, reduce harmful human-wildlife interactions, and ultimately enhance the success of reintroduction programs or the safe capture and release of species from dangerous sites. One particularly fascinating application of sensory ecology and conservation is the concept of reducing ecological traps. An ecological trap occurs when an organism mistakenly chooses a poor quality habitat over a better, available one, simply because it misinterprets cues about habitat quality. In our human-modified landscapes, we've inadvertently created countless such traps. Man-made materials, mimicking natural surfaces, can fool organisms into making bad decisions with potentially fatal consequences. Take solar panels, for instance. To many insects, these expansive, dark surfaces reflect horizontally polarized light in a way that closely mimics the shimmer of water. Insects, instinctively driven to lay their eggs in water, are lured to these panels, attempting to oviposit on what they perceive to be an ideal nursery. The tragic result is widespread juvenile insect mortality. Sensory ecologists, understanding this optical deception, have devised a brilliant mitigation strategy. By breaking up the uniform shape of the solar active areas on the panels, they made them less attractive to insects, significantly reducing mortality. It's a simple change with a profound ecological benefit. Bats, those fascinating navigators of the night, also fall prey to ecological traps born from our smooth, artificial surfaces. Research has shown that bats don't necessarily detect water by its wetness, but rather by the smoothness of its surface, which creates distinct acoustic reflections. Consequently, they attempt to drink from perfectly smooth, non-water surfaces like sheets of glass. Each futile attempt wastes precious energy and time, which can ultimately decrease their fitness and survival rates. Understanding this sensory reliance allows us to develop strategies to make such surfaces less appealing or even to add texture that signals the absence of water. Birds, too, are frequent victims of ecological traps, particularly in our increasingly vertical world. A major focus of avian sensory ecology has been to understand how birds perceive colossal structures like wind turbines and towering buildings. Each year, countless birds perish in collisions with power lines, fences, wind turbines, and the very glass facades of our architectural marvels. The flight paths around these structures, while appearing as viable corridors, function as ecological traps, dramatically increasing bird mortality. Sensory ecologists have illuminated the underlying reasons for these tragic collisions, linking them directly to avian sensory biology. Unlike humans, whose vision is predominantly binocular and provides high-resolution frontal focus, bird vision is much less so. They often lack the high-resolution frontal vision that would allow them to clearly perceive large structures directly in front of them, especially at speed. It's as if they are flying through a world where solid obstacles appear only at the last, fatal moment. Fortunately, this understanding has spurred a wealth of proposed solutions. Studies on airport lighting schemes, for instance, have revealed that different patterns elicit varying responses from birds, suggesting that strategic alterations can significantly reduce bird strikes. Other researchers have put forth ideas for ground-based warning sounds or visual cues, designed to alert birds to potential hazards long before they become an immediate threat. By intelligently adjusting the sensory cues that birds rely upon, ecologists are actively working to dismantle these avian ecological traps, making our skies safer for our feathered friends. Beyond the realm of conservation, sensory ecology has proven to be an incredibly potent force in pest management strategies. Here, the exploitation of specific senses is ingeniously employed to control insect, marine, and amphibious pests. Managers have leveraged sensory ecological insights to craft highly individualized visual, pheromonal, and chemical traps. Consider the tsetse fly, a notorious vector for African trypanosomiasis, or sleeping sickness. These flies, it turns out, are strongly attracted to specific shades of blue. Scientists believe this preference stems from blue colors mimicking the appearance of the ground beneath a shady tree, a crucial refuge for flies seeking to escape the intense heat of the day. Armed with this knowledge, blue fabric traps, often imbued with pesticides, are strategically deployed to lure and eliminate these disease-carrying insects. The exploitation of visual cues also extends to the control of aphids and whiteflies, common agricultural pests. Many aphid species exhibit a strong preference for yellow. This attraction is thought to be linked to their preference for yellowing leaves, which tend to have higher concentrations of easily accessible nitrogen sources. By understanding these visual preferences, yellow sticky traps are used to monitor and reduce aphid populations, protecting valuable crops. Perhaps one of the most sophisticated applications of sensory ecology in pest control involves pheromones. Pheromones are species-specific chemical cues, incredibly potent in their ability to influence the behavior and physiology of other organisms of the same species. When released, they can trigger powerful behavioral responses, from mating rituals to alarm signals. Because pheromones are largely species-specific and elicit such strong, predictable reactions, scientists and managers have harnessed their power to lure and trap a vast array of pest species. This method has been particularly successful in insect populations, proving effective against sugarcane weevils, gypsy moths, invasive oriental fruit flies, bark beetles, and various Carpophilus species. It's a testament to the elegant precision with which sensory ecology can be applied to complex environmental challenges. From the disorienting glare of city lights on migrating birds to the subtle scent of a pheromone guiding an insect to its doom, the field of sensory ecology continues to reveal the hidden complexities of life on Earth. It reminds us that our world is not a singular, uniform experience, but a mosaic of countless Umwelten, each unique, each exquisitely adapted to its particular needs. As we navigate the challenges of the Anthropocene, this deep understanding of how organisms perceive and interact with their environment becomes not just a scientific curiosity, but an essential tool for stewardship, conservation, and the continued thriving of all life on this vibrant planet. We've journeyed through the intricate landscapes of perception, explored how the symphony of nature is being silenced by our own making, and witnessed the dazzling, yet disorienting, effects of our artificial lights. Now, as our exploration of sensory ecology draws to a close, we arrive at a fascinating crossroads. How this profound understanding of other creatures' worlds is being harnessed, not just for knowledge, but for tangible solutions in the grand theater of conservation and pest management. This isn't merely academic curiosity. It's a practical, often ingenious, application of empathy and scientific insight. It's about stepping into the Umwelt of another species and asking, what information are they gathering? How are they interpreting it? And how can we gently, or sometimes firmly, guide their decisions for the betterment of ecosystems and often for their own survival? Consider the concept of the ecological trap, a hauntingly poetic term for a very real and often tragic phenomenon. Imagine a bird drawn to a shimmering surface, believing it to be a bountiful lake, only to find it's a vast expanse of solar panels, reflecting horizontally polarized light that mimics water. For many insects, this perception is fatal, as they attempt to lay their eggs on these deceptive surfaces, leading to widespread mortality. Bats, too, are fooled by smooth, reflective surfaces like glass, mistaking them for calm bodies of water, wasting precious energy and time trying to drink from nothing. These aren't foolish choices on the part of the animals. They're the logical outcomes of sensory systems evolved over millennia to interpret natural cues. The problem arises when we, as humans, introduce novel environments and materials that mimic these cues, but lead to dead ends, or worse. Sensory ecology provides the crucial lens to understand why these bad decisions are made. By dissecting the specific information organisms are using, we can then devise strategies to mitigate these traps. For instance, by breaking up the uniform, reflective surfaces of solar panels, researchers have found them to become less attractive to insects, significantly reducing this unintended mortality. The skies, too, are fraught with these sensory deceptions. Birds, with their unique visual systems, are often oblivious to the colossal structures we erect. Our binocular vision, with its high-resolution frontal focus, allows us to easily navigate around buildings and power lines. But for a bird whose vision is much less binocular and lacks that same frontal acuity, a looming wind turbine or glass skyscraper can become an invisible killer. Millions perish each year, caught in these aerial ecological traps. But here, understanding leads to action. Sensory ecologists have proposed solutions ranging from altering airport lighting schemes to placing specific warning sounds or visual cues on the ground. By subtly adjusting the sensory landscape we create, we can help these winged navigators perceive and avoid the dangers we've inadvertently introduced. It's a testament to the power of seeing the world, literally, through another's eyes. Beyond conservation, sensory ecology is proving to be a formidable tool in the realm of pest management. Instead of broad-spectrum, often environmentally damaging approaches, scientists are employing highly targeted strategies that exploit the very senses of the pests themselves. It's a sophisticated game of sensory manipulation. Take the tsetse fly, a notorious vector of African trypanosomiasis, or sleeping sickness. Scientists have discovered these flies are powerfully attracted to specific shades of blue, a color that, to their sensory system, mimics the cool, shaded ground beneath a tree, a vital refuge during the heat of the day. Armed with this knowledge, blue fabric traps, imbued with pesticides, become incredibly effective lures, drastically reducing fly populations without widespread chemical application. Similarly, the humble aphid, a bane to many crops, exhibits a strong preference for yellow. This isn't random. Yellow leaves often signal higher flows of accessible nitrogen, a crucial resource. By deploying yellow visual traps, managers can effectively control aphid populations. And then there are pheromones, the invisible whispers of the natural world. These species-specific chemical cues can elicit incredibly powerful behavioral and physiological responses. For insect populations, pheromone traps have become a cornerstone of pest control, luring species like sugarcane weevils, gypsy moths, and invasive fruit flies into designated areas, either for monitoring or eradication. It's a precise, elegant solution, leveraging the inherent communication systems of the pests against themselves. But the application of sensory ecology isn't solely about preventing harm or controlling pests. It's also about restoring, about actively creating conditions that promote life and biodiversity. Imagine the concept of a soundscape, the collective symphony of an ecosystem. We've seen how anthropogenic noise can degrade these soundscapes, masking vital communication. But what if we could restore them? Research has shown that playing loud, diverse, and healthy soundscapes can actually have the power to restore once degrading coral reefs. It's an auditory beacon of hope, attracting larvae and supporting the long-term stability of these crucial marine ecosystems. Ultimately, the integration of sensory ecology into conservation and management strategies offers a powerful, nuanced approach to our relationship with the natural world. It helps us understand why different species react to environmental changes in their unique ways, and crucially, how we can mitigate the negative impacts of our own actions. By understanding the vastness of the perceptual worlds experienced by other species, we can prevent ecological and sensory traps, reduce human-wildlife interactions, and ultimately increase the success of reintroducing species into new habitats or safely relocating them from dangerous sites. This field, relatively new yet profoundly impactful, reminds us that the universe is perceived in a myriad of ways, far beyond our limited human senses. It challenges us to look deeper, listen closer, and feel the subtle vibrations of other lives, allowing us to build a more harmonious and sustainable future for all inhabitants of this incredible planet. And as we continue to unravel the mysteries of these diverse Umwelten, we gain not just scientific knowledge, but a deeper, more profound respect for the intricate, often invisible, tapestry of life. As our exploration of sensory ecology draws to a close, remember that the universe isn't just out there, it's also deeply within the way every organism experiences its reality. From the unseen magnetic fields guiding a bird's migration to the acoustic highways of the ocean, every creature crafts its own unique world. I hope this journey has offered you new perspectives and perhaps even a moment of calm reflection. If you enjoyed this deep dive, please consider liking this video, sharing it with someone who might appreciate it, and subscribing to join our growing community of cosmic thinkers. I'd love to hear your thoughts in the comments below. What resonated most with you tonight? And what scientific mysteries would you like us to unravel next? Until our next journey into the wonders of existence, good night and keep exploring.